So basically the surface area of a cone formula is pi r squared, which is the circle at the base of the cone. And then you've got pi r L, which is the area of the curved surface of the cone. Now you need to be careful, this L here represents the slant height, so the height of the edge outside of the cone, not the height inside of the cone. So keep that in mind. And then you've got surface area of a sphere, which is just basically 4 pi r squared. Okay, so we're going to try and apply these formulas to all these variety of questions here. So let's start with question 2b from your exercise that you actually got to do. So in this question, girls, notice how they've given you the diameter of the circle to start off with, not the radius. So obviously the radius of diameter of 4 meters is just 2 meters. So you just need to keep that in mind. So don't just plug into the formula. Make sure they've given you the radius, not the diameter. So the radius is 2. We've got the slant height. So now we just have to basically plug it in here. So we've got pi times the radius squared, that's 2 squared, plus pi times the radius times the slant height, which is just 2 times 8. Okay? So if I put all of this in the calculator, 0.8 meters squared. Okay? Alright, now let's have a look at question 3c. In this situation, girls, again, they've given you the diameter, not the radius. So the radius is obviously half of that, which is 7 millimeters. But in this question, they haven't given you the slant height, they've given you the perpendicular height. So let's have a look at this triangle over here. And yes, we do need to use Pythagoras Theorem. So we're trying to basically find x, okay? We know that's 24. We know this is half of 14, which is 7. So in order to find the slant height, actually, let's call it L since we're finding slant height, which is represented by L. L is basically then 24 squared plus 7 squared. And then square rooting that would give you this, you want to get 25, okay? So that's the number that you want to work with, all right? So we've got our radius. So using that formula, surface area is now equal to pi times the radius squared plus pi times 7 again times 25, okay? And that should give you, they want everything in exact value. Okay, if you read the question, it says calculate in exact form in terms of pi. So that means what you want to put in the calculator, is just 7 squared plus 7 times 25, okay? Leaving the pi's alone. So if I put 7 squared plus 7 times 25 in the calculator, 224, okay? So once you get that number, you just have to put pi next to it and then write the unit, millimeters squared. Okay, so that's what they want you to do if they want you to find your answer in exact form. Let's have a look at sphere. So as we know, the formula for surface area is 4 pi squared. And again, they've given you the diameter, not the radius. We want half of that. So 10.8 divided by 2 is what we want to work with, which is 5.4. And then use this in the formula. It's pretty straightforward with this one. So 4 pi times 5.4 squared. And then if you put that in the calculator, you're going to get 366.4 centimeters squared. Okay, that's pretty straightforward. But it's not so straightforward when they give you a hemisphere, which is half of a sphere. You need to keep in mind with this question, you need to not only find the surface area of the outside curve, but you need to also add the area of the top circle on top. Okay, so a lot of students forget to do that, so make sure you do that. Okay, the only time you don't add the circle on top is if the question says open hemisphere. But if you look at the diagram for question 5a, it's not. So make sure you find the area of the top as well. So let's find the radius to start off with, because obviously it's a diameter here. Half of 24 is 12 meters. So the surface area of a hemisphere to start off with is half of a sphere. Half of 4 is 2. So to start off with, the formula is now 2 pi r squared for the curved surface outside, plus the area of the circle on top, and area of a circle is just pi r squared. And what you'll notice if you actually look at that, they're the same thing. So it's just you doing 2 plus 1. So you could write this whole thing as 3 pi r squared. Okay, so this is your the surface area of a hemisphere formula if there is also circle on top. So using that, so the answer is just 3 pi times the radius squared. Okay, and do they want us to find an exact form? Yes, they do. So if they do, just do 3 times 12 squared in the calculator, and then you'll get 432, and don't forget to write the pi next to it and the units. Okay? It's another hemisphere. Same thing, including the circle at the bottom and then the curved surface outside. But here's the tricky part. 16 here represents the radius, okay? It's actually not the diameter, because if I was to draw another hemisphere underneath it, let's say this is one whole sphere. As you can see, this 16 millimeter represents the radius of a sphere. So don't think this 16 represents the diameter. It's not. It's actually the radius. That's what I wanted to point out in this question. And then you basically have to do the same thing here. Just plug it in here. 3 pi r squared, like we established. It's just 3 pi times 16 squared. And that should give you the answer. Okay? Okay. Girls, I got question 8 wrong the first time. Okay? It's actually a pretty tricky question. So let me explain it to you again. So find the amount of sheet metal needed to form a conical funnel of base 30 centimeters and vertical height 50 centimeters, allowing for a 0.5 centimeters overlap at the joint. All right, so let's make one thing clear. It says find the amount of sheet metal needed to form a conical funnel, okay? It just says conical funnel. What you need to realize with conical funnel is there is actually no circle on top. That's the tricky part, okay? So all they want you to actually find is the curved surface of the cone, okay? Now, I'm going to draw this cone as a net, okay? So basically, all they want you to find is the area of this, okay? So this is how it would look like if I laid this cone out flat, all right? So this is a net, okay? Now, the question is, okay? Now, I told you there is no circle, but let me draw like an invisible circle to show you what the radius, just to label the radius with it, okay? So what they've told us is that the radius is 30 centimeters, okay? Vertical height is 50 centimeters, so that's the perpendicular height, okay? So from here, that would be this, okay? And we've got the radius of 30 centimeters there. Now, allowing for a 0.5 centimeter overlap at the joint, that means there is an extra piece of metal here, okay, where that's 0.5 centimeters there, okay? So it's just an extra layer of metal to help glue the conical funnel, okay, better, okay? It's just an extra bit of rectangular sheet of metal. So what we need to do is basically find the area of this and find the area of that and add them together, okay? Not including the circle, okay? But the reason why we need that number 30 centimeters is we need to find this length here, okay? Because that actually represents the slant height, okay? So we need to find that, okay? So let's draw this out like that. So right now we have 50 centimeters here, okay? And the radius formed is 30 centimeters. So this is the bottom here, 30 centimeters. So to find the slant height, which is that bit there, using Pythagoras straight away, it's 50 squared plus 30 squared. All right, so let me figure out what this is. I'm going to leave it in this form. I'm not going to evaluate that square root 3,400 because it gives you a decimal number and I don't want to round it. So what we need to do now is just find the surface area. So the surface area is just that, which is pi RL, plus this is actually a rectangular flap. So we got the rectangle, which is just length times width, okay? So your answer is pi times the radius, which is 30, times the slant height, which is root 3,400, plus the length of this, once again, is root 3,400 times the width, which is 0.5. Okay? If you put all of this in the calculator, you should get the answer at the back of the book. So let me just try it out. See the answer. Okay, 5525. Okay, so this is quite a tricky question. A lot of students also from last year struggled with. So hopefully this should clear it up. There are a few more trickier or harder questions like 10 and 11, but I'm going to let you girls try that out on your own, okay? Try the exercise out now, and if you have any questions, just let us know on Google Classroom. Okay, thanks.